Good morning and welcome back to our Future of Food and Farming Summit. We hope you have enjoyed our session so far. For those who are just joining us, my name is Gabriela Galindo and I'm an agri-food reporter for Politico Europe. We're now going to start a conversation about gene-edited foods after we discussed the role of future technologies in a previous panel. And before we begin, I would just like to remind you to tweet about the event with your comments using our hashtag PoliticoAgriFood, and to submit any questions you may have for the panelists through the swap card. This discussion is rightly entitled Separating the Wheat from the Chaff. So hopefully by the end of it, we'll be able to know what's what between those two names. So genetically engineered foods have been sort of floating back up in the agri-food agenda. We heard just this morning from US Secretary for Agriculture, Tom Vilsack, that there is a potential for the EU and the US to look in the same direction when in integrating these new technologies into the future recipe for the agri-food world. Why is that? Because they are looking to them as a solution for climate challenges, sustainability challenges. And so what we're going to discuss today is where do we stand from a policy standpoint, and we're going to try to see what everyone's views there are. On the EU side, a recent report from the European Commission called the Strategic Foresight Report, which is this sort of obscure paper that they put out, setting out the main challenges for the future for global challenges. They said of new genomic techniques that they could play a key role in developing innovative and sustainable ways to protect harvests from pests, diseases, and climate change. Amid all of this, there's also some sort of a terminology battle about what to call these new technologies. Those who are developing them have gone for the term new breeding techniques, while those who are a bit more wary of them would like them to continue to be called new genetic engineering techniques or even new GMOs. So from the EU side, where do we stand? The European Commission's research wing recently put out a study in which it concluded that the current framework for regulating genetically modified organisms is not necessarily applicable or is no longer fit for purpose for the new genomic techniques that are now being developed. So to discuss where we're headed with these technologies, I am very happy to introduce our speakers who are joining us online. We have Mr. Tassos Haniotis, the Acting Deputy Director General for the Commission's Agriculture Department. We have Sabine Jülicher, the Director of Food and Feed Safety in the Commission's Health Department. We have Mr. Timothy Searchinger. He's a senior researcher at the Center for Policy Research on Energy and on the Environment at Princeton University. And we have Mr. Jan Plage, President of Organics Europe, an association that represents organic farmers' interests in the European Union. Thank you all for joining us. And to get started, I think I would first like to address Mr. Searchinger. I would like to sort of discuss what these technologies can do at the moment. What can they do for farmers and for policymakers looking to tackle challenges of sustainability, of climate adaptation, of improved yield, and of nutrition?
Sure. So the debate about genetic engineering has been dominated by the fact that the vast majority of genetically engineered crops in use do one of two things. Either they make it possible to use glyphosate, Roundup ready crops, so they make it possible to use glyphosate without killing the main crop, or they incorporate BT, which is a protein that's a natural insecticide. And the biggest issue with those is that they lead to kind of a continuous use of these two different pesticides, in effect, either the applied pesticide glyphosate or the inbred pesticide, which actually tends to have a short-term advantage for sure, but leads to weed resistance. And so everything has been seen through those eyes. But genetic engineering can do a lot of other things. So, for example, in the future, there's a possibility that we can have a low methane rice variety. There was a paper in Science a few years ago where that was achieved in part just by adding a single gene from barley into rice. There is genetically engineered resistance to disease that has, in many cases, proven to be the only way of actually avoiding the wipeout of different crops. There may be breakthroughs in photosynthesis even that could speed that up. So the potential there does seem to be a potential to have some breakthrough technologies that could help reduce emissions and increase yields, increase nitrogen use efficiency, et cetera, et cetera. And so the question is, can those be realized? Will the debate be dominated by these first two traits? And there's a lot of suspicion. And the suspicion is that, in fact, they won't be used to achieve these environmental goals. And I think part of the story is that to get the world, the people to accept this new technology, there has to be a demonstration that that's really what they'll be used for.
Great. That's definitely part of the debate that we're looking to have, how to really reap the best benefits out of these technologies. So we have heard that there's definitely potential in addressing the challenges of sustainability and climate change that I mentioned earlier. I would like now to perhaps turn to the Commission. Why does the European Commission have an interest in applying, boosting these technologies and integrating them into the recipe for the future? Perhaps Mr. Haniotis, you can tell us why.
I could tell you why from the agricultural point of view. I thought that my colleague Sabine would start first because it's a regulatory aspect that is a priority. But in terms of the agricultural part, it's very clear that while agriculture has had major achievements in the last decades in terms of the economic and its social performance, it is very clear that when it comes to environmental performance, its performance is clearly not what we would have liked, despite the fact that we have had some positive effects. And it's especially something that we need to improve a lot and increase the overall level of ambition if we want to address climate change. And climate change comes with very specific risks in agriculture, because the change in climate affects the conditions of production everywhere in all sorts of climates. We have more diseases, both for plants and for animals. We have more cases of drought and extreme weather events, and there is a need for new varieties that we need to address this particular type of issues. Of course, new varieties is not something that is unknown in agriculture. In fact, many breeding techniques, all the way from conventional to modern biotechnology, try to do that. What these new techniques have been shown to be able to do is to actually advance the knowledge that is necessary. And we have seen that whether it is on animal health or plant health, we have seen it also very clearly with vaccination, with existing techniques in public health as well. So it is a way of actually catching up delays we have in addressing a more sustainable footprint of agriculture that would make the advance of these techniques pretty important. But I hope the discussion will come out also with the pros and cons that come with this. Thank you.
Definitely. Yes, thank you. And since you mentioned regulation, that is indeed the hot topic now. How is exactly the European Commission thinking of regulating these, and are they thinking of regulating them differently than the current GMO regulation? And first, I would like to know from Ms. Jülicher, what applications is the Commission interested in for these new technologies? Are we looking only at food, gene-edited food, or will it go beyond that? Can you tell us a bit about that? Yep.
With great pleasure. First of all, hello to everybody. Thanks for listening in. And maybe before I venture into my contribution here, I would like to inform you that just today, the Commission has put the roadmap for its policy initiative on the topic out. We have the concept of an inception impact assessment, which sets out the context, the problem definition, and proposes certain areas that the Commission would want to study in depth. And this roadmap, as I said, has just been published. So there you will find a lot of answers. And the beauty of this roadmap is also that, it is out there for 4 weeks consultation. So we are really looking forward to the views of everybody interested on our thoughts. So what you just asked, and I think that is also interesting to discuss in the overall context. As the Commission has laid out already in May last year in its Farm to Fork strategy, I mean, we have and we would like to look at various ways to make the food chain, the food system more sustainable. As you are aware, there are many reflections for many parts of the food chain, but we have also recognized that we should really look at the potential of new genomic techniques to improve sustainability. And sustainability is a broader concept than just for food. Let's think about feed. Let's think about other applications to capture carbon. So it is a potentially wild feed again, wild field that can be used. As you will see, we see currently the biggest potential on plants obtained with certain techniques, targeted mutagenesis and cisgenesis. These are, I would say, the genomic modification that are least invasive, if I may say this. So we're looking at the field of plants, and that could be plants for food production, that could be plants for feed production, that could be plants for other applications as well. Thank you.
Okay, great. It's great that you mentioned the impact assessment. That was one of the questions I really wanted to ask about, and it's good to know that it's out today. Can you let us know a bit more about what is in it, and who are you going to ask for contributions for it?
Well, we are asking basically everybody. Everybody who is interested is invited to enter the portal, have your say, and contribute to the discussion. Because as for many other policy initiatives, I mean, this is something we would like to discuss broadly. So everybody can have their say. We are expecting contributions, obviously, from the known interested stakeholders, but this is going as far as providing the opportunity for the individual citizen or third country government, whoever. So I think the roadmap gives already a good idea, what is the problem we are trying to address. The problems you could already see coming out of the study that the Commission has delivered to the Council just in April this year. There was already a fairly good idea what problems we have. These are legal uncertainties. These are problems of enforceability. These are problems that actually we have no mechanism these days to take into account whether products of new genomic techniques have a potential to contribute to societal challenges. We have problems of appropriate risk assessment. So all of these problems the policy initiative intends to tackle, and the roadmap sets out, which areas we are, or which policy elements we are going to study more in depth. So it's not yet an options paper, but it clearly sets out, which are the areas that we would like to study more in depth. Thank you.
Thanks. I would like to turn to Mr. Plagio now. We have heard that there is indeed interest into these new technologies for all of the challenges that have been mentioned before. And one of the most striking goals that the EU is trying to pursue at the moment is to cut pesticide use in half. We heard just yesterday as well at the UN Food Systems Summit that there is a great interest of world leaders to really tackle the Sustainable Development Goals, improve nutrition, do away with hunger. And I want to ask, is the solution for this ready-made crops, and what is the organic sector's view on that? And is this a sustainable pathway to pursue?
Thank you for the invitation and the possibility to discuss it. Yes, for the organic sector, this is not an option, and it's not a smart option. The Commission chose, or they choose objectives, targets, which has to be reality by 2030, and this is a quite short period. And they want to change agriculture and food systems, and not only to solve just one problem with just one technique. This is an old approach. Just have one disease, and then we have one trait, and then we have a new monoculture in the old way of thinking how the industrialization of agriculture systems works. And so with these new challenges, what we face, that we have to really deliver on the loss of biodiversity, on climate change, on adaptation, etc. We have much more problems than solving just with breeding. Breeding is one important solution, but we have to deliver much more, changing the agricultural and food systems. And already in this discussion, you can see that politicians and citizens are quite confused about this genome editing discussion. So we are discussing now if the terms are right. I mean, this is not the real problem. If you have a genetic editing technique, it's a genetic technique, and a new term is not solving these problems. And the other confusion is the question of priorities. The Commission, on one hand, says we want 25% organic farming, farmed land, and consumer confidence and demand, etc. So 1/4 of the whole agriculture and food system should be organic, and this is the quickest and the cheapest way of reducing pesticide. In 95% of all organic managed land is zero pesticide used. And this is already one of the biggest contributions what farmers and food processors, retailers can deliver by using organic for this transformation.
Thanks. I would like to turn to Mr. Haniotis and also Mr. Searchinger. Mr. Plagio just said that this is not necessarily the best way to go for organics. And he mentioned, indeed, rightly so, that the Farm to Fork strategy wants to expand organics and organic production in the EU. Is it, in both of your views, something that is developing new genetic techniques and new ways of new genomic techniques and organics? Are these two mutually exclusive ways of farming, or can they coexist? And if they can they do so in a fair? Can they be in fair competition? And what are the risks just what are the risks there?
Do I start?
I'd like to start. Yes.
Okay. Let me start. Well, first of all, I agree fully with Jan that we have a priority to strengthen organic farming. But I also agree with him that we have the fact that we go towards 25% organic farming does not mean that we ignore what are the challenges in the rest of the 75% of land. In fact, it is extremely important for the organic farming as well to coexist with methods of production and practices that all increase their level of ambition when it comes to climate action and reduce the environmental footprint. And it's not only an issue with what we do with pesticides. It's not only an issue on how we reduce the use of fertilizers. It's also an issue of how new diseases are more resistant to changes in climate and the potential for the generation of new diseases. I think there are several people that know, and I'm economists and not a pure scientist. For some, economists are not even scientists, but from the pure scientist point of view, there is plenty of evidence that indicates that there are inroads that can be made that would help improving the capacity of crops to resist better in the new climate condition. The real issue that we have to address is what is the confidence that we have in this and other type of technologies, because conventional breeding techniques exist and they don't come up without risks and without problems. And here it would be important to define, and not only at the end, but even in the middle of the discussion, what is the wheat and what is in the chaff and what we're discussing. If the chaff is the noise, the waste, the deception, if you want, metaphorically, that's how it's used in the military terms. The wheat has to be the scientific process and the reliance on the scientific process. Science does not come with absolute truths, and it always comes with what is called either the margin of error or the confidence interval. And it's very important to discuss what is this acceptable confidence interval and how is it established so that all practices demonstrate a better capacity to reduce their environmental footprint than today, and that practices like the organic farming are not put at risk because of what exists in their neighborhood. And this is, I think Jan knows very well, an issue that already exists today. It's not an issue that you have to start discussing with any type of techniques. And a final point, and I think it is extremely important when we talk about confidence, and especially confidence of the public, one of the biggest mistakes done at the early stages of this process of biotechnology is the use of terms that indicate very little understanding of the perceptions and the fears that citizens have. I mean, there's nothing worse than the term of genetic engineering, especially in the European historical context. I mean, but that should not move us away from the substance of what exactly is the scientific process that we're talking about. What are the procedures, the rules, and the manner by which we're going to assess the safety of the products that are going to come out for the consumer, for the producer, and for the environment. And I'm pretty comfortable that my colleagues in DG Santé have all these elements in the regulatory process that will guarantee this safety in the process. Thank you.
Thanks. Yeah, that was also another topic that I wanted to tackle, and I would like to perhaps just really quickly let Mr. Serginger reply to this question of organic market and new genomic techniques coexistence before I hand over to Mrs. Jülicher for the question of risks.
Well, typically organic is defined to exclude genetic engineering, any genetically engineered crops. So by definition, if you make that part of your definition, then it doesn't play a role. The real issue is what should our objectives be? Reducing pesticides is one important objective, but the biggest challenge we have is we need more or less 50% more food globally by 2050, and we need to produce all that food on the same land And we need to do it while reducing greenhouse gas emissions from the production process by 2/3. This is a gigantic challenge. And if you only focus on pesticides, let's say, you only focus on what genetic engineering can achieve, you're not defining it by this broader outcome. So from my perspective, you have to look at all of the above. It's absolutely true that we need to look at a huge variety of things, including shifting diets, reducing our meat consumption. We need to look at reducing a whole range of techniques for reducing pesticides. But we basically need to do everything we can to produce more food on the same land in order to preserve forests and their carbon and their biodiversity. And in Europe, because Europe has a stable population, it has the potential to restore a lot of forests too, which is also important from a carbon standpoint as yields rise. But Europe exists in this global context of massively rising food demand and continuing deforestation. And those are the overwhelming challenges. And one of the questions I have is Europe really going to consider that? There's a real risk that Europe will simply offshore its land use requirements, export less, import more, use land for bioenergy instead of for food production. And to embrace these challenges, you need to embrace every possible solution.
I just want to really go back to this question of risks, and because it's one of the big issues in the debate before also addressing how the Commission is going to regulate. So I'm going to have to go a bit quickly now. I would like to ask Mrs. Jülicher, how is the Commission tackling this question of risks? What are the risks you are looking at? And I would also, in the same go, like to address some criticism from non-profit organizations who are opposed to the Commission's assessment that the current framework is not fit for purpose. They think that the current GMO regulation can apply to new genomic techniques and should apply to it, because what it entails is labeling requirements, risk assessment requirements, and traceability requirements. So I would like to, they are saying that the Commission is not putting enough research funds into the risks that these technologies can bring, that the Commission is putting a lot of funds on applied research, but not a lot on risk research. So I would like to ask you to respond to those criticisms and to tell us more indeed about the risk assessment process that the Commission is considering.
Thank you very much. First of all, to the discussion we had so far, I mean, I cannot agree more to Mr. Plage and to Mr. Searchinger and Tassos, of course. You know, what we are trying to tackle here is complex, and obviously innovation, and this particular innovation through the potential of new genomic techniques is just one element. Our problem is far bigger and wider, and that's why we firmly believe that we have to look at the potential contribution of every technique, of every piece of innovation. This being said, I think we can't repeat it sufficiently enough. We are not prepared when looking at modification of regulation to in any way lower safety standards. And safety standards, I am convinced, are extremely high in terms of animal health, in terms of human health, and in terms of safety of the environment. And this is a precondition where we are not moving away from. What we have learned through science, and I think this has to be also a bit the basis of our discussion, to accept scientific findings. What we have learned through science is that we would even find more appropriate ways of risk assessment than those that we have under the current framework. In particular, when we use a little bit of foresight with regards to the products that we will soon see appearing on the market. And I just would like to contribute as well to really recommend the JRC Science for Policy report that looked at current and future market applications of new genomic techniques, because here we can see how many applications are in the pipeline, what are their particular traits, what they can potentially contribute. And, you know, the issue will be, amongst others, to have a risk assessment process that is really adapted to the product and the particular modification. And let's face it, with new techniques, you can modify a bit and you can modify massively. So you can't just say because someone is using a particular technique, this is more or less risky. We really have to be a bit more specific also in the risk assessment and look case by case. And lastly, I would still want to remind that the future process, in our opinion, should also be able to look at the contribution to sustainability of each of the developments, because that's what we need. If I may be very clear, we are very open for innovation here in Europe, but what we are particularly open to is innovation that helps us to address challenges on sustainability. Thank you.
Thanks. I would like to jump off that question, that answer, sorry, and ask a question to the Commission again, to either of you who would like to reply. As was mentioned by Dr. Sertinger at the beginning, current gene-edited crops have focused on pesticide resistance and herbicide tolerance. So a question that I would like to ask is, what makes you think that the new generation of gene-edited crops will focus on all of the sustainability aspects that you say are so needed and that you say the Commission is willing to support? Do you think that, how can that change this time around?
Well, I think we just have to look at the evidence, and as I say, I mean, I'm quoting here from the JRC report, because they are saying, you know, we have classified 16 plant applications at the pre-commercial stage. They were looking globally, and they said, yes, there are some plant trait combinations that are similar to those already developed with herbicide tolerance, but there are also trait combinations, and this is evidence, I mean, we are not making this up, which relate to fungal resistance, modified nutritional composition, resistance to drought or heat. I mean, this is the evidence that is there in the applications that are currently under development. And I'm convinced that many of these applications have the potential. I'm not saying all of them, but many of them have the potential to address sustainability questions. And we know that through regulation, you can basically tease out those and bring them in the foreground. I just want to remind, for example, in the pesticides area, we have modified regulation a couple of years ago. We have prioritized low-risk pesticides, and the market is responding, the developers are responding, and today I see close to 50% of the new applications are low-risk pesticides. So it can work.
Great, thank you. We have a question coming in from the audience that kind of will take us back to this question of risk assessment. Perhaps this is one for Dr. Sertinger. Pamela Dissack asks, how far are we in terms of scientific knowledge on the effect of gene-edited food on consumer health? I think a lot of the criticism as well that has come up from those who are more wary of these new technologies is that it can create what's called off-target results, so unintended changes. So could Dr. Sertinger perhaps respond to these questions? How far is science in detecting these and preventing them?
Well, so far, there are essentially no indications of human health problems from any genetically engineered crops. The debate tends to focus not on the modified gene, but rather whether glyphosate is bad. So the gene allows the application of glyphosate when the question is that bad or not? And even for that, it's pretty clear that glyphosate, which is an herbicide, is less bad than a lot of other herbicides, but when you apply such massive amounts, the question is, are you still getting some problems? But it's not the actual gene change. The scientific community is pretty much unanimous, or almost unanimous, in thinking that what should really focus is the nature of the modification, whether it's achieved through genetic techniques or through conventional breeding, which dramatically transform crops all the time. I mean, the idea that our crops are extraordinarily artificial creations from thousands of years of breeding and lots of recent changes, with huge changes in their genome, huge changes in their traits. So the focus should be on the trait and its risk, rather than on the fact that you've used a genetic technique or for modifying the gene, rather than just other so-called conventional techniques, which can be very changing, right? You can use radiation, for example, to cause changes in genes, and then test those out and see what they affect. That's not considered genetic engineering. So that's basically, I think, a consensus is, so far, no problems. If in the future there could be, but that's true for conventional breeding as well. And we should be focusing on the trait that's changed, not on how you achieve the trait.
Right. Yep. So this kind of ties in with what Ms. Juliher said, that the risk assessment and the regulatory framework that is being thought of should focus rather on a specific trait rather than on a broad technique. I would like to bring Mr. Plage in now. I would like to ask, is this what the organic sector need in terms of plant breeding regulation? Is this, in your view, aligned with the Green Deal targets? And what does your sector want to see in terms of regulation there? Very quickly, we have 5 minutes.
Yes, for the organic sector, it is very important that the new regulation still address a precautionary principle and a risk assessment, traceability, and a labeling, so that the freedom of choice is still there for the farmer, for the breeders, that they know with which methods in the process, in the breeding process, was worked on, and at the end, for the consumer, for the citizen to decide if I want a product which was produced or breeded by this new genome editing practices. And for us, this safeguards the coexistence, which was already addressed, and where we have a lot of doubts that coexistence with these new technologies and a new regulatory frame is possible, because many of the companies they doesn't put their process, their breeding process into databases and into knowledge what we can use in detecting the results and detect them if we can still work with genome editing, genome technique free produce. And let me address a last comment, which is already a problem today, are the costs. So who is paying the cost of organizing the coexistence? Today, more or less, the organics has to pay, or the organic consumer has to pay. We have a study from 2017 of a socio-economic study of the cost of the current genome techniques or crops with GMOs like maize or soya. And in all these related products, the costs are between 0.4 and 0.8 of the whole turnover, which has to include in the whole value chain. And that's what we address to the Commission as well, not only to focus on the risk on ecosystems or on health aspect, but on socioeconomic aspects as well. So we can't pay for the risk and the cost of new technology we don't want to use.
So how, in your view, can these two ways of farming coexist? What is the best avenue possible to relieve the burden of the costs from the organic sector? How can the Commission best support you on that?
Yeah, if we have a clear principle which calls a polluter-based principle, so that that those companies who introduce new varieties are responsible for the cost of analysis and detection. If the neighbors and the neighbor farms and the neighbor companies still can produce without these, and this is the main question: is how to introduce in the regulatory frame the polluter-based principle.
Is this something that the European Commission is looking to keep in the new framework that it is thinking of for the technologies? I don't know if. Oh, this is a question to the Commission.
If I may, I mean, just to pick up on what Mr. Plage said, you know, the Commission has no intention, or the other way around. I mean, we have a very strong intention to foster and support organic production. I mean, we spoke about the 25% target. We have just launched an organic action plan. Tassos is much more into that. And we are very much subscribing to the principle of coexistence, because we firmly believe, you know, we have to have a variety of approaches to agriculture and food production to solve our problems of today and the future. We are in Europe very much subscribing to the concept of traceability, labeling, freedom of choice, and I cannot see that, especially on this topic, which is sensitive to many, who would in any way move away from these principles. So in the end, and I'm in a way very pleased that Mr. Plage said, you know, we have already issues nowadays, and that we hear that and we acknowledge this, and I think our new framework is we are set out to address these challenges. Now, when it comes down to costs, I think what would be very, very important is, you know, to have reflections how this can be solved. I cannot tell you now how exactly that can be solved, whether it will be the instrument of this regulatory framework that can solve these issues, but it's certainly something to be further considered in the work we are having in front of us for the next year or so. Thanks.
Thanks. I would just like to, really quickly, Mr. Haniotis, if you would like to add something, we're going to wrap up.
Very briefly and telegraphically. First of all, very strong point, the role of public research in building up confidence, especially of consumers, of what is coming out. Second, the polluter principle applies in pollution. What is the issue we're talking about? We're not talking about producing products that pollute, but that reduce the existing level of pollution. That's an important thing to keep in mind. So we need to separate process from the product. Third issue, what is very important, is to look at the manner by which the problem we have to solve is going to be addressed. And fourth, and that is also, I think it should be of comfort to Jan, it's not only the organic that we strengthen. We strengthen also methods and practices like a stronger crop rotation and reduction of damage in the soil that would exactly promote the type of new breeding techniques to generate seeds that will help in that direction instead of generating more risks.
Thanks. I would like to wrap up with just one broad question. We have seen that we don't all agree on everything on these subjects, but is there something that we can all agree that we want and from new gene-edited technologies? Very quickly, just like a round table, or do we not agree at all?
Reading is very, very important.
Oh.
Everybody together.
Everybody together. Yes, Dr. Serchinger, really quickly, do you agree with, is there something that is possible or that we do want from gene edited technologies? I think I'm running really out of time.
Yeah, we want whatever they can contribute to this extraordinary challenge we have, which is we need to produce more or less 50% more food on the same land while reducing the methane and nitrous oxide and the energy use in agriculture by about 2/3. And that is a huge, huge challenge. And that means we need higher yields, we need resistance to disease, and we need new ways of producing things that are more efficient in terms of nitrogen use, produce less methane. And this is only genetic engineering, or is only one way of contributing toward that. It will not solve the overall problems, but can help. And so the basic thing is appreciate the magnitude of the challenge and embrace all potential solutions.
Yep. Mr. Plugger.
Yes, I think what we all agree and what we discussed and heard is that breeding is very important. It's one important technology: classical breeding, participatory breeding, involving farmers, reaching yield stability, built-in resistance, etc. So it is very important, but it's not the only solution. That's what we all discuss, and I think this is a common opinion. And we have to adapt the agricultural systems as a whole, and using organic agroecological methods, as Tassos mentioned. I think that's what we can agree on, and not just focusing on one new technology.
Yep. The Commission, just to wrap up.
So the problem is,
perhaps everything has been said.
The problem is complex. So the solutions have to be complex and in many layers, and we should definitely use our brains and our science to be able to exploit the potential that is in new genomic techniques. With caution, with many principles in mind, but we should not prohibit ourselves from reaping the benefits. Thank you.
Thank you. I don't know, Mr. Haniotis wants to add something, or
my starting point is that we need, and I think we all agree that the type of problems that we need to prioritize are problems that are stemming from climate change. And if this is the focus, then I think more and more we'll start realizing that there is a whole spectrum of best practices and techniques that are available right there that could help in that direction. And that should be the criterion that would allow us to assess in the process which are the ones that are more acceptable than others.
Thank you. Okay, so we have to wrap up. We look forward to the contributions to this impact assessment that was just launched today. Thank you to all the panelists for their time and contributions. Thank you to the audience. And stay tuned for a discussion on soil health coming up with my colleague Eddie. Thanks very much.